Yes, very possibly. All right. So, um, great learning. Great learning usually begins with curiosity, and so that's why I put these type of problems up here. Shh. If you can become curious about something, it doesn't have to be math. But be curious about something. Otherwise, you don't have a whole lot of interest in pursuing your studies moving forward. So, we look at this type of problem. We've been talking about taking antiderivatives. As you look at this type of problem, do you know what the antiderivative is? Very good. So what I need to do is I need to multiply this out 4 times and then distribute the 3x squared. Does that sound fun? Wouldn't it be nice if there was an easier way of doing it? And so what I'm going to do is I'll reference now this dx. This dx refers to a number of different things. First of all, it does refer to the width, as we talked about earlier, but it also refers to that this is a derivative, okay? This is a derivative. It comes from something. So, for example, notice if I take the derivative of 4 plus x to the third, what do you get? If I take the derivative of that, what do I get? 3x squared. And because we came up with a derivative, we say it's dx. 3x squared dx. All right? We're just going to put that there for this piece. You notice how that relates to this problem right here. Right, and so what I do is I use something called substitution to find the antiderivative. And you'll see how this works. We'll take a decent amount of time with this first one, then we'll be able to move on a little bit more quickly with the rest. I say that u is equal to 4 plus x to the third. Remember when we did the chain rule and we chose what the inside was? Often with integration, and you do substitution, you choose u to be the inside piece. So in this case, you're taking it to the 4th power. After you write down u, you write down du. Du is the derivative of u. What is the derivative of 4 plus x to the third? 3x squared dx. I can now do a replacement. And the replacement means instead of working with a variable of x, I will work with a variable of u. So notice that if I write this integral, and instead of putting a dx at the end, I put a du, that means I've gotten rid of 3x squared, and I've gotten rid of dx. Instead of writing 4 plus x to the third, what can I write? I can write u to the 4th power. See, 4 plus x to the third is u. And it's that to the 4th power. So the du takes care of the 3x squared and the dx. That's this substitution. And then 4 plus x to the third is taken care of by u. What is the antiderivative of u to the 4th? U to the 5th over 5 plus c. Well, obviously, we are working with the variable x, not with the variable u. What do you think I plug back in for u? 4 plus x cubed. That is now to the 5th power divided by 5 plus a constant. That's the antiderivative. So what would you take the derivative of, in order to get this, you take the derivative of 4 plus x cubed to the 5th power of 5 plus c. I don't write this down, but let's just verify that that's correct. You would use the chain rule to take that derivative, correct? And you have u to the 5th over 5, where u is 4 plus x cubed. What is the derivative of u to the 5th over 5? U to the 4th. What's the derivative of this? And so you get 3x squared times 4 plus x cubed to the 4th power. And it's a derivative, so we write dx. So you can see here in this substitution piece what we have. To get this, yep. Yes. And so I just verified by taking a derivative that I came up with the right answer. Kaylee? Well, sure, yeah. No. I'm confused as well. I'm not quite sure exactly where the question is. Yeah? Yeah, that's what we did right here, right? The antiderivative of u to the 4th is u to the 5th over 5. Okay, so I understand what you're suggesting, but that is the easiest problem you will ever see regarding substitution. Okay, we want to be able to handle much more challenging problems where it'll be a little bit more difficult. And I would say that this is a level 2 type problem. Then tomorrow or on Tuesday, we want to show you problems that are significantly more difficult, where when you take the derivative of x to the 3rd, you don't get, there's no 3x squared. In fact, there's no x squared. So how do we account for that situation? We could take the derivative of anything, folks. Antiderivatives, this is one technique. And there's many techniques out there that are rather involved. Right now, we're teaching you the most important technique. Okay, let's look at number 2. This is a substitution problem. What do you think u is in this scenario? 4x squared minus 3. What do you think du is? 8x dx. I won't mark it wrong, but in college it was marked wrong for me. So as you look at this piece right here, we have u is 4x squared minus 3. Now, some people wondered why I didn't write 7x here, because they saw the 7x. So you don't just write whatever you see. You have to write what the derivative is. Now, I want a 7x. I don't have a 7x. I have an 8x. So I'm going to just divide by 8 to get 1/8 du is equal to x dx. Now I'm going to get rid of the 1/8. I want to create a 7 in front of that x, correct? Because I want a 7x. Agreed? So I'll multiply through by 7. I get 7/8 du is equal to 7x dx. So look what I have. Instead of the 7x dx, I put 7/8 du. I'm going to put the 7/8 out in front of the integral. Doesn't matter where the multiplier is. I'll put the du right here. So the 7x is gone and the dx is gone. Instead of 4x squared minus 3, what should I write? U cubed. Well, that's an easy antiderivative to find. What's the antiderivative of u cubed? So 7/8 times u to the 4th over 4 plus a constant, which is 7 times. What is u? Raised to the 4th power over 32 I'll say constant. That is the antiderivative. Substitution is a technique that you will use for the rest of the year. It is the most important technique for finding antiderivatives that you will use. Take out a scratch sheet of paper. What I would like you to do right now is I would like you on a scratch sheet of paper to try to find these two indefinite integrals. Use substitution. Yes. 4x cubed times 2x to the fourth plus 1 to the 10th dx. And then we have the integral of negative 2 times 5x plus 3 to 100 dx. Again, these are the basic type of problems before we switch things up a little bit. We have to get these before we feel confident moving on. Give them a shot. I'll give you some time here. Okay, so the first one, you should get 2x plus 1 to the 11th over 22 plus a constant, dy line. Yep. Anybody questions on that one? Anybody make a mistake that they want to share on that one? Yeah. This one? So I said negative 2/5 du is negative 2 dx. No, that's totally illegal. You would have to multiply this out 101 times before you distribute the negative 2. Order of operations comes first, right? So negative 2, 5x plus 3 to the 100 first power, divided by 505 plus c. You know, we would use Pascal's triangle, but that in and of itself would be ridiculously, you know, they create computer programs for that kind of stuff. So, yeah, Adam, there you go. Okay, just maybe grab an extension assignment instead. Okay, flip back to your notes. Good job. So you guys feel okay with that so far? Okay, let's move on to stuff that's just slightly more challenging then, okay? So as I looked at it, I don't think we'll be able to fit the test in next week. So I think it'll fall to the next week because we're going to do harder problems in this, and we're going to do some practicing in class, and your study guide is super lengthy. So, okay. All right. So, and we salvaged a few days from first semester. So second semester a little bit longer, and so you know, we have some time to kind of just play around and have some fun. So, all right. What do we? Any idea what U is going to be here? What's on the inside? Yeah. So when in doubt, I can't say it's always correct, but when in doubt, choose what's on the inside. And notice if you just make a choice, just try taking the derivative. What is the derivative of the root of x? So, do you see a root of x in the denominator? Yeah. I've got these constants, negative 2 over 3, but who cares about that? So I'm going to have the, I have u is equal to then that root of x. Du is equal to 1 over 2 roots of x dx. I want to create a fraction of negative 2/3. So I'm going to multiply by negative 4. We'll pick up with there when we get back. We've got, we chose u to be the square root of x, which means du is 1 over 2 roots of x dx. I multiplied through by negative 4 to come up with negative 2 dx over the root of x. So now I just got to divide through by 3. So I get negative 4/3 du is equal to negative 2 over 3 roots of x dx. So whatever you need to multiply by or divide by, you can play around with that constant however you want. And we now have our substitution. So I'm going to put the negative 4 over 3 integral, and I'll put the du. Negative 2 is gone. 3 roots of x is gone. And dx is gone. So what remains? Cosine of what? A lot of people want to get rid of the cosine. I'm not worried about getting rid of the cosine because I know what the antiderivative of cosine is. What's the antiderivative of cosine? It's just sine. So I have negative 4/3 times the sine of what is u? Root of x plus constant. What do you think? Oh, I always forget to change this. Should not be a tangent squared. It should just be tangent. If it was tangent squared, that would be a little bit more challenging. So. Okay, what is u in this problem? And the reason why that is important is because when you take the derivative, what's the derivative for? 0 on the derivative of tangent is secant squared of x dx. So again, that's important because you can see the secant squared of x dx shows up right there. So this becomes a very simple substitution. We have u to the third du. I appreciate your enthusiasm and bringing humor to our class. Antiderivative is u to the fourth over 4 plus a constant. So 4 plus tangent of x, all to the fourth power over 4 plus that constant. So you see the power of substitution, right? Okay, let's continue to try some problems that might be a little bit more challenging for you. A lot of people don't like problem number 5 or 6. Let's do them anyway. That's the attitude. What do you think u is in this problem? The reason why I like 1 minus x squared is because when I take the derivative, I come up with an x. I'm not so worried about the 3, but I do come up with an x. So du is equal to negative 2x dx. I don't have a negative 2x dx. What should I try to get? The 3x dx. So I'll multiply by 3, and I'll divide by negative 2, right? So I have negative 3/2 times the integral du of what? What's left? 1 over the root of u, which is u to the negative 1/2. What is the antiderivative of u to the negative 1/2? Yeah, so I get negative 3 over 2 times 2 roots of u plus c. What happens? Negative 3 root of 1 minus x squared plus a constant. If I take the derivative of this, what should I get? Yep, what we have at the beginning. What is u? du dx. Yeah. Yes, yes. Yes. Is this a 1? Yes. It's just too short. Is that the issue? Oh. Yeah, very good, because I need the 4x plus 2. Multiplying through by 2 works. Can I just show you just very shortly how difficult I can make this? If instead of a 2, that was a 3, I'm just saying that, folks, we know how to take the derivative of anything, but it just takes a small change, and all of a sudden the antiderivative becomes much more complicated. In this situation, we'd have to use a process called partial fractions decomposition and integration using that. And so, right. Okay. But I want you to appreciate that it just so happens that multiplying through by 2 works out really well. If we change this to a 3, then all of a sudden, got nothing. Okay. So, good. So I got 2 du is equal to 4x plus 2 dx. I have a 4x plus 2 dx right there. So I got a 2 integral of something du. What do I have on the inside there? U to the negative 3? What's the antiderivative of u to the negative third? U to the negative 2 over negative 2, right? So 2 times u to the negative 2 over negative 2 plus c. The 2's cancel. I get negative 1 over Yep. So this is a 2 over 1, and yep. So I end up with negative 1 over x squared plus x minus 1 squared plus your constant. Okay? All right, last 2 types of examples. And again, tomorrow you'll have time to work. Okay? So, what makes this problem different? E to the x. Now, remember, the derivative of e to the x is e to the x. Isn't that beautiful? What's great about this is the derivative of e to the x plus 1 is also e to the x. So do you think what do you think should be u? Do you think we should have u be e to the x or e to the x plus 1? Very good. So u is equal to e to the x plus 1. It does. It won't work out the other way. Well, pardon my statement there. So there are times where it could work out, but in this situation, e to the x plus 1 is definitely the correct choice. Du is equal to e to the x dx. I have an e to the x dx. It's sitting right there. So I now have an integral du. Yeah, u to the negative 1 or 1 over u, as I'll write it. We're just waiting. So u to the 0 over 0, right? It does exist. Come on, folks, first semester. Oh, goodness. Wow. Okay. I'm sorry, YouTube. We ate a bowl of stupid for lunch. I know he said it, but I was waiting for somebody else. So if you take the derivative of natural log, you get 1 over x. You guys remember that. It was on our final exam. We had tons of problems like that. Don't act like you don't remember. I know it's so long ago. It was a whole month and a half. Okay, stop it. You're all F for everybody. Darren passes. Everybody else, you're done. All right. All right. You said it? All right, Maddie said it. Okay. All right. Pity vote for you. All right. So the antiderivative is natural log of u, and then we have a plus c. What is u? So it's the natural log of e to the x plus 1 plus a constant. Yes, exactly. That's all of your arc sign. Yep. Yes, you have. Yeah, without a doubt. Yep. This one? Okay, excellent point. This is a classic example of what do you decide u is. So Kelsey is seeing this problem through, and she's saying, suppose that u is equal to cosine of x. It's not. So if we say u is cosine, then du would be negative sine of x dx, right? And we have a 4, so negative 4 du is equal to 4 sine of x dx. Well, I multiply by a negative 4. So watch what happens here. Watch what happens with my substitution. So I have negative 4 times the integral. Watch what gets replaced, okay? Instead of cosine of x, what do I have? I have u. And the negative 4 in the du replaces the sine of x, right? So what is it that's squared? But the sign is replaced, we said. Just one of the signs is replaced, isn't it? So you still have a sign of x sitting in there, because you've only gotten rid of one of them. See that? So unfortunately, that substitution doesn't work very well. If we change our substitution and instead we say u is equal to sine, and I like that because sine is being squared, sine sits on the inside, then du is equal to cosine of x dx. No, and you'll see why. I need a 4, so 4 du is equal to 4 cosine of x dx. So I have 4 times the integral of u squared du. So that's why I don't worry about the squared, because I know the antiderivative of u squared. What's the antiderivative of u squared? So I have 4u to the third over 3 plus a constant. What is it that we are cubing? So 4 sine cubed of x divided by 3 plus your constant. That's my final answer. Integration by substitution is one of the foundational pieces. In fact, you guys, this is the majority of your second semester final and your third quarter and fourth quarter final. Substitution. That's what you're going to have to do over and over and over again. Not subtraction. Yeah. You have all day tomorrow to work on this, folks. But here's what you can't do. We do not have school on Monday, do we? You cannot show up on Tuesday and be super behind in math. I would say when you come in on Tuesday, you should be caught up with all of your math and have all of the problems done except for the ones you just can't figure out from this assignment. Because trust me, we've got some challenging assignments ahead of us yet. I would say in terms of substitution problems, I gave you level 1 and level 2 type problems. We still have level 3 and level 4 type problems to get to. Okay? Let's say 4. All right. You guys will go have a great Tiger Day.